Let us see the Python operators. Here we are going to discuss about arithmetic operators, comparison operators, assignment operators, logical operators, bitwise and numbership operators in Python. Arithmetic operators. Arithmetic operators are used with numeric values to perform commonly used mathematical operations. Here you can see that addition, subtraction, multiplication, division, modulus. This is called as an exponential and floor division. These are the normally commonly used arithmetic operators available in Python. Similarly, there are various comparison operators are there. Less than, less than equal to, greater than equal to, not equal to are some comparison operators over here. You can see here. Equal to indicate the comparison between the two variables. Is x is equal to y? Answer is true or false. Remember that equal to is a comparator operator and only equal to is an assignment operator. Here a is equal to 10 means we are assigning value 10 to variable a, and a is equal to b means we are checking is the a is equal to b or not. So the comparison operators always has output in Boolean format, either true or false. Logical operators are and, or, and not. These logical operators and returns true if both the statements are true. For example, for AND operation, if x is less than 5 and x is less than 10, then return true. If both the condition occurs true and true, then it will return true. If any one of the condition occurs false, it will return false. For AND, if x is less than 5 or x is less than 10, if any one of the condition occurs true, it will return true. Otherwise, it will return not reverse the result. Means if result is true, it will provide false. If result is false, it will give true. Return the false if the result is true, or return the true if the result is false. So these are the logical operators. Few bitwise operators are and, or, and not. Here you can say the operation is and. It is also called as a pipe. It is also called as a tilde symbol. Bitwise operators work on each bit. They are doing bit by bit comparisons. This AND sets each bit to 1 if both the bits are 1. This OR set bit to 1 if one of the two bits is a 1. And this not to the reverse of all the bits. For example, suppose we have 10 and 20. So we can have a binary equivalent of 10 as 0, 0, 1, 0, 1, 0. This is a binary equivalent of 10. And for 20, we have 0, 1, 0, 1, 0, 0. So we can do the bitwise AND operation. So it will look like 0, 0, 1, 0, 1, and 0. And for 20, 0, 1, 0, 1, 0, 0. This bitwise operator 0, 0 will occur 0, 0 will occur 0, 1, 0 will again 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. So in case of AND, if a situation occurs like 1 and 1, then only it will be 1, else or the zeros. Similarly, you can understand for the OR. For OR, it will be 0, it will be 1, 1, 1, 1, 0, and 1. And for NOT, it simply reverse the things. So 0 will be converted to 1 and 1 will be converted to 0. Another and the last operators we are seeing today is membership operators, which are in and not in. In operator returns true if sequence with specified values is present in object. Not in return true if sequence with specified values is not present in the object. Let us understand this by using a Jupyter code. X is equal to, we create the list. In the list, we have two names like apple, banana. Here we have created a list. Now you can see here I'm printing print banana in X. So the output is true because banana is a part of X list. It's true. So if it is not part, print, it will return false. Likewise, you can understand the purpose of X. Suppose I can write print mango not in X. It will return true because mango is not part of X list. So this is what we have seen about membership operators. Thank you for your patience listening.